Okay, in this lesson we're looking at a summary of our probability topic. Now, probability is the chance of something happening. We can use words to describe that. So, for example, what is the probability that I will take a breath today? Well, hopefully that is a certainty, so we use the word certain. The Dockers will win the A-League. Well, the Dockers are an AFL team, and the A-League is a soccer comp, so we'd say that's impossible, just couldn't ever happen. If I toss heads when I flip a coin, well, there's a 50-50 chance, heads and tails, so we call that 50-50 or an even chance. The probability of a baby being born on a Tuesday, well, there's 6 other days in the week it could have been born on, so it's not impossible, but it is unlikely. And the probability of you watching TV tonight, for most of us, that would be likely. So there's an example of us using words: certain, impossible, even chance, likely and unlikely, to describe the chance of something happening. We can also use numbers to calculate probability. And this term we use up here is theoretical probability, is where we can actually calculate a number to represent probability. And the way we do that is we work out the number of successful outcomes, we'll talk about that in a moment, and divide it by the number of possible outcomes. Let's have a look at an example. If I roll a 6-sided die, there are 6 possible outcomes. 1, 2, 3, 4, 5, and 6, the 6 numbers on the die. A successful outcome will depend on the question that I'm asking. So if I asked what would be the probability of rolling a 4, then rolling a 4 would be considered our successful outcome. What would be the probability of rolling an even number? Well, on a die there are 2, 4, and 6 are the even numbers. So there are 3 successful outcomes out of the 6 possible outcomes. So on this 6-sided die, what's the probability of rolling a number greater than 4? Well, we have 6 possible outcomes, and we have 2 successful outcomes, which would be 5 and 6 are the only 2 numbers that are greater than 4. So we work out our theoretical probability. On the top of our fraction, we put the number of successful outcomes, which we decided was 2, and divide by the number of possible outcomes, which is 6. And that means we've got a probability of 2/6. We can simplify that to be 1/3 as our answer. Another term you might come across is experimental probability. Well, this is when we get results from actually doing an experiment and record the results. So for example, if we tossed a coin 100 times and got 56 heads, we would say that the experimental probability of tossing heads was 56 out of 100, because there's 56 successful outcomes out of the 100 possible. Or we could simplify that to 23/50. The more experiments we do, the more likely that the theoretical and the experimental probability will get closer to each other. So theoretically, if we use our theoretical probability on that, we would say that the probability of tossing heads should be 50 out of 100, because it's 50/50. The more experiments we do, the closer those two will come together. We call that a sample size. So if we have a large sample size, we're more likely to get the answers being closer together. So if I tossed 10 coins and recorded my results, the answer would be different, probably, than if I tossed 1,000 times. Probability is always written as a number between 0 and 1. So if I take this little formula here, we've got 0 is less than or equal to the probability, which is less than or equal to 1. So it sits somewhere between 0 and 1. And remember, the probability, if something has a probability of 0, we call it impossible. A probability of 1 means that it's certain, and a probability of 0.5 means that it's an even chance. Let's have a look at how we calculate those numbers and why they are correct. Let's go back to our 6-sided die and ask, what is the probability of rolling an integer? Well, from our work on integers, we know an integer would be on a die. There are 6 of them. 1, 2, 3, 4, 5, and 6 are all integers. So the probability of rolling an integer, we have 6 possible outcomes, and we have 6 successful outcomes. So the probability is 1. It's certain. What's the probability of rolling a 7? Well, there are no 7s on a die. So the probability, there are 6 possible outcomes, but there are 0 successful outcomes. So the probability of rolling a 7, which is impossible, works out to be 0. What's the probability of rolling an odd number? There's 3 of them, 1, 3, and 5. So the probability equals 6 possible outcomes. And we have 3 successful outcomes, which calculates to be half or 0.5. Finally, let's look at what we call the complement. Now, the complement, I'm going to write this little formula which reads as follows. The probability that something is not A equals 1 minus the probability of it being A. Now, that's a little confusing, but let's look at some examples. But the most important thing to remember is that an event and its complement add together to equal 1. So their probabilities must come together to equal 1, which covers all options. So if I made a statement that said the sky is blue, the complement to that would be the sky is not blue. Making a statement like the sky is red is not a complementary event because it doesn't cover all of the other possibilities. The probability I will roll an even number, the complement to that is I will not roll an even number. Or you could say I'll roll an odd number, because even and odd still cover all the possibilities. So let's go back to our die one more time and have a look at how we calculate this. If I wanted to know what's the probability of rolling a 6, I could say it's 1 over 6 because there's 1 successful outcome over 6 possible outcomes. So the complement to that is the probability of not rolling a 6. Now I could work it out using our theoretical probability by saying, well, there are 5 successful outcomes over 6 possible outcomes, gives me 5/6. Or more easily, I could say, well, they are complementary events. So the probability of rolling a 6, the complement is the probability of not rolling a 6. And I know that the probability is 1 minus the complementary event. So let's have a look at that. I could say the probability of not rolling a 6, which was my what we worked at here as being 5/6, I can say is 1 minus the probability of rolling a 6. So that is 1 minus 1/6, which equals 5/6. One last example of a question you may get regarding probability. A red, yellow and blue ball are randomly placed next to each other. What is the probability that the blue and the red are adjacent? And by adjacent we mean they're sitting next to each other. So the first step here is just list all the possible outcomes. 3 balls placed randomly on a shelf. It could be red, yellow, blue. It could be red, blue, yellow. Blue, red, yellow. Blue, yellow, red. Yellow, red, blue. Or yellow, blue, red. Step 2 says we'll count the successful outcomes. So we're looking for any arrangements that have the red and the blue next to each other. And as I look through them, I find that there's 4 of them that have the R and the B sitting next to each other. So the probability equals the number of successful outcomes, which we decided was 4, over the total number of outcomes, which is there are 6 possible arrangements. So the answer to that is 4/6, or we can simplify that to 2/3. And that concludes our summary on probability.